This is General Mathematics, Class 12, Chapter 1, Applications of Matrices and Determinants, Exercise 1.1. Question number 1, find the adjoint of the following. Subdivision 1. Here one matrix is given. Solution. Let the given matrix, let us take A. Here A is equal to minus 3, 4, 6, 2. Then adj of A, place changing the leading diagonal element, that is 2 here, other diagonal elements sign changing, minus 4, then minus 6, minus 3. This is the adjoint of A for 2 cross 2 matrix. Subdivision 2. Let A is equal to 2, 3, 1, 3, 4, 1, 3, 7, 2. Let us take the given matrix as A. Now, before going that adjoint of A, we can find out the cofactor matrix. Cofactor matrix. Cofactor matrix is denoted as Aij is equal to, find out the minor of each and every element of the given matrix. That is, what is the first element here in row 1 and row column 1? What is the first element here? That is 2. What is the minor of 2? Here the question is row 1 and column 1. The minor of 2 is, ignore that first row and first column. This is the position of 2. Ignore that first row and first column. Remaining elements are the minor of 2. That is 4, 1, 7, 2. This is plus. What is the next element here? In first row, second column, 3 is here. What is the position of 3? First row and second column. Ignore that first row and the second column. What are the remaining elements here? 3, 1, 3, 2. That is minus of 3, 1, 3, 2. Next one, first row, third column. The position of 1 is first row and third column. Ignore that first row and third column. What are the remaining elements? Plus 3, 4, 3, 7. In second row, first column, the position of 3 is second row and first column. Leave that, ignore that second row and first column. What are the remaining elements? 3, 1, 7, 2. 3, 1, 7, 2. Next one, the position of 4 is, the element 4 is second row, second column. Leave that second row and second column. What are the remaining elements? 2, 1, 3, 2. 2, 1, 3, 2. Next one, the position of 1 is second row, third column. Ignore that second row and third column. What are the remaining elements here? 2, 3, 3, 7. 2, 3, 3, 7. Next one, in the third row, first element is 3. Third row and first column. Ignore that third row and first column. What are the remaining elements? 3, 1, 4, 1. 3, 1, 4, 1. Next one, 7. The position of 7 is third row and second column. Ignore that third row and second column. The minor of 7 is 2, 1, 3, 1. 2, 1, 3, 1. The last element 2. The position of 2 is third row, third column. Ignore that third row and third column. What are the remaining elements? 2, 3, 3, 4. That is called as the minor of 2. Minor of 2 is 2, 3, 3, 4. All the elements covered within the square bracket. Here alternative signs are changed. Here plus, minus, plus. This is minus, plus, minus, plus, minus, plus. Now we can simplify the elements here. Now Aij, what is the another element of cofactor matrix? Aij. Aij is equal to plus what I said, simplifying the determinant value, product of the leading diagonal element, then minus of other diagonal elements. Product of the leading diagonal elements, main diagonal elements 4 into 2 8, then minus of other diagonal elements 7. Next one, then minus of product of the leading diagonal elements, that is 3 2s are 6, then minus 3. Next element plus product of the leading diagonal elements 21 minus 4 3s are 12, minus 12. In the second row, then minus of product of the leading diagonal elements 3 2s are 6, then minus of 1 into 7, 7, minus 7. Next one, plus of product of the leading diagonal elements 2 into 2 4, then minus 1 into 3, 3. Next one, minus of product of the leading diagonal elements 14 minus 9. In the third row, here plus of product of the leading diagonal elements 3, then minus 4 into 1, 4. Next one, minus of product of the main diagonal elements, that is 2 into 1, 2, minus of 3 into 1, minus 3. Next, plus of product of the leading diagonal elements, that is 4 2s are 8, minus 3 into 3, 9, covered within the square bracket. Now we can simplify Aij, 8 minus 7, 8 minus 7, that is 1, 6 minus 3, 3, then minus of minus 3, next 21 minus 12, that is 9, here 6 minus 7, that is minus 1, minus of minus 1 plus 1, here 4 minus 3, 1, we get 14 minus 9, 5, then minus 5, 3 minus 4 minus 1, minus 1, minus of minus 1, that is plus 1, we get 8 minus 9, minus 1. What is the question here? Find out the adjoint of the given matrix. Adjoint of A is equal to Aij, the whole transpose. What is transpose? Transpose means transposing the number of rows and columns. Interchange the rows and columns, that is called as transpose. Adjoint of A, Aij. What is the cofactor matrix? 1, minus 3, 9, 1, 1, minus 5, minus 1, 1, minus 1, transpose, with the transpose. Here, adjoint of A, interchange the number of rows and columns, that is adjoint of A is equal to, what is the first column? 1, 1, minus 1, 1, 1, minus 1, second column minus 3, 1, 1, minus 3, 1, 1, and the third column 9, minus 5, 9, minus 5, minus 1. This is known as adjoint of A. Next one, third subdivision. Here question number 1, subdivision 3. Students, let us see question number 1, subdivision 3. What is given here? 1 by 3, the first matrix 2, 2, 1, minus 2, 1, 2, 1, minus 2, 2. The given matrix, let us take A. Let A is equal to 1 by 3 into 2, 2, 1, minus 2, 1, 2, 1, minus 2, 2. The given matrix can be taken as A. What can we find now? Adjoint of A. Adjoint of A is equal to, adding adjoint both the sides, then adjoint of 1 by 3 into, what is the matrix given here? 2, 2, 1, minus 2, 1, 2, 1, minus 2, 2. Now, we have to work out this problem. I can use this property, adj of lambda A is equal to lambda power n minus 1 into adj of A. Using this property, students, in our textbook, page number 8, we have 6 properties are there. This is one of the property. This is very useful to you. Adj of lambda A is equal to lambda to the power n minus 1 into adj of A. Now, we can use this property here. Here, adj of lambda A. Comparing these two equations here, adj of lambda A is equal to lambda power n minus 1 into adj of A. Comparing these two equations here, adj of lambda A. What is the value of lambda? The value of lambda is 1 by 3. Substitute the value of lambda in this equation. Here, adj of A, the value of lambda is 1 by 3 to the power n. What is n? That is order of the matrix. What is order of the matrix? What I said? First we have denoted as number of rows, after that number of columns. How many rows are here? 3. Number of columns is also 3. That is 3 by 3. Order of the matrix is 3 by 3. So, here n is equal to 3. Therefore, n is equal to 3. Substitute the value of n here. Lambda is 1 by 3. The value of n is 3. 3 minus 1 into adj of A. Adj of A. What is the value of 3 minus 1? That is 2. 1 by 3, that is equal to 1 by 3 to the power 2 into adj of A. Now, we can find out the value of adj of A. A is here. What is the value of adj of A? Here A is, what is A? 2, 2, 1, minus 2, 1, 2. What is the third row? 1 minus 2, 2. 1 minus 2, 2. First of all, we can find out the cofactor matrix. How can we find out the cofactor matrix? Cofactor of A is equal to, what is the first element here? The first element is 2. What is the first element here? First element is 2. The position of 2 is first row. The position of 2 is first row and first column. Ignore that first row and first column. Write down the remaining elements. That is the minor of 2. That is the minor of 2. So, 1, 2, minus 2, 2. This is minor of 2. What is the second element here? 2. The position of 2 is first row and the second column. Ignore that first row and the second column. Remaining elements are the minor of 2. Remaining elements are the minor of 2. So, minor of 2 is minus 2, 2, 1, 2. In the first row, third element is 1. Ignore that first row and third column. What are the remaining elements? Minus 2, 1, 1, minus 2. These are the elements are minor of 1. That is minus 2, 1, 1, minus 2. Next one. In the second row, first column, the element is minus 2. Ignore that second row and first column. What are the remaining elements here? 2, 1, minus 2, 2. 2, 1, minus 2, 2. This is the minor of minus 2. Next element is 1. What is the position of 1? What is the element 1? Position of 1 is second row, second column. Ignore that second row and second column. What are the remaining elements here? 2, 1, 1, 2. 1, 2. So, minor of 1 is 2, 1, 1, 2. What is the next element? 2. Position of 2 is second row and the third column. Second row and the third column. So, position of 2 is second row and the third column. Remaining elements are, that is 2, 2, 1, minus 2. This is the minor of 2. Next, consider the third row. Third row, first column, 1. Position of 1 is third row and first column. Ignore that, third row and the first column. What are the remaining elements here? 2, 1, 1, 2. Next, minus 2. Next element is minus 2. Ignore that, third row and the second column. The remaining elements are 2, 1, minus 2, 2. 2, 1, minus 2, 2. This is the minor of minus 2. The last element 2, the position of 2 is third row, third column. Ignore that, third row and the third column. What are the remaining elements here? 2, 2, minus 2, 1. This is the minor of 2. Minor of 2 is 2, 2, minus 2, 1. Covered within the square bracket. Then cofactor matrix can be written as Aij. Now put the alternative sign, first one plus, because position of 2 is plus, here minus, this one is plus. So plus, next sign is minus, next one plus, minus, plus, minus, plus, minus, plus. What I said, how can we calculate the determinant value? Product of the leading diagonal element, that is 2 into 1, 2, then minus of minus 2 into 2, that is plus 4. The value of the first determinant is product of the leading diagonal element, 1 into 2, 2, then minus of 2 into minus 2, that is minus 4, minus of minus 4 is plus 4. Next one, minus of product of the leading diagonal element, that is minus 2 into 2, that is minus 4, then minus of 2 into 1, 2. Next one, plus sign, minus 2 into minus 2, product of the leading diagonal element, minus 2 into minus 2, that is plus 4, then minus of 1 into 1, 1. Consider the second row, minus of 2 into 2, product of the leading diagonal element, 2 into 2, 4, then minus of minus 2 into 1 plus 2. Product of the leading diagonal element, 2 into 2, 4, then minus of minus 2 into 1 minus 2, minus of minus 2, that is plus 2. Next here, sign is plus. What is the product of the leading diagonal element? 2 into 2, 4. Then minus of 1 into 1, 1. Next here, sign is minus. Leading diagonal element, product of the leading diagonal element is 2 into 2, 4. Then minus other diagonal elements, product of the other diagonal elements is 2 into 1, 2. In the last row, here sign is plus. Product of the leading diagonal element, 2 into 2, 4. Then minus 1. Next, minus of, how can we find out the determinant value? 2 into 2, 4, 4, then minus of minus 2, minus of minus 2 we get plus 2. Next one, plus 2 into 1, 2, then minus of minus 2 plus 4. Now simplifying this Aij matrix, Aij is equal to 4 plus 2, that is 6, here minus 4, minus 2, then minus of minus 6 plus 6. Next one, 4 minus 1, the third element, 4 minus 1, we get 3. In the second row, 4 plus 2, 6. Then minus 6. 4 minus 1, that is plus 3. The next element is minus 4 minus 2, that is minus 6. Minus 6 into minus plus 6. Next one, 4 minus 1, we get 3. Next 4 plus 2, 6, that is minus 6. 4 plus 2, 6 plus 6. Now we can find out the adj of A. Adj of A, 6, 6, Aij, the whole transpose. What is the cofactor matrix? 6, 6, 3. In the first row, 6, 6, 3. In the second row, minus 6, 3, 6. In the third row, 3, minus 6, 6, transpose. Here, interchanging the rows and columns, that is called as transpose. Therefore, adj of A is equal to interchanging the rows and columns. Here 6 minus 6, 3, then 6, 3, minus 6, 3, 6, 6. This is adj of A. Now we can substitute the value of lambda here. Therefore, adj of A is equal to 1 by 3 into 1 by 3 into, this is the value of adj of A, 6 minus 6, 3. What is the second row? 6, 3, minus 6, 6, 3, minus 6. What is the third row? 3, 6, 6, 3, 6, 6. Next, adj of A multiply by 1 by 3. 1 by 3 to the given matrix. Adj of A 1 by 3 into, divided by 3 in each element, 6 divided by 3, minus 6 divided by 3, 3 divided by 3, then 6 divided by 3, 3 divided by 3, minus 6 divided by 3. What is the third row? 3 divided by 3, 3 divided by 3, then 6 divided by 3, last one 6 divided by 3. Therefore, adj of A is equal to, what is the scalar here? 1 by 3. So, 2 minus 2, 1, 2, 1, minus 2, 1, 2, 2. That's all. This is the value of adj of A.